Okay, thank you. Well, today we are going to do. Could you please off the microphone? Thank you. Today we are going to do applied and simple things related to statistics for sure. Well, before we learned theoretical and I suppose very abstract topics, but today we have to learn how to apply these topics in practice to solve practical problems. For example, yesterday you had to show descriptive statistics for returns of Gazprom and Rosneft. And we estimated average returns, we estimated standard deviations of returns and tried to interpret them. But what if one asks me, what is the probability to get a return between 0.5% and 1%? Well, or what is the probability to get a daily return between 0.03 and 0.07? Or what is the probability to get a average daily return lower than 0? i.e., what is the probability to get negative daily average returns? Today we are going to learn how to apply one simple tool in statistics to solve this problem. What else? In addition, we have to continue the discussion about sampling distribution. We have to review concepts of unbiased, efficient, and consistent estimator. And after that, we should learn more about probabilities and distributions. We should learn how to solve a following exercise. Imagine you know that average return of a stock is 5% per annum. What is the probability that average annual return is between 4 and 6%? Well, and today we should learn it. And finally, if we have sufficient time, we can discuss confidence intervals, or we can skip them to the next week. And for sure, today we have to work with data, and the first thing we have to do is data, because in data we should learn how to calculate descriptive statistics, how to create box plots, and for sure how to open data in Stata. Hence, everyone, now please open Stata, and I'm going to share my screen to show what we have to do in Stata and how we have to do in Stata. Well, this is Stata. Guys, are you ready? Type plus if you are ready. Thank you. I suppose that your interface looks like this. Well, first, in Stata, by default, we have 4 important areas. The first area is the main area. Here you can find basic information about the program, name of the program, its version, copyright, phones, and information about the license. Well, this area shows outputs. This area shows solutions of different exercise that we do in Stata. Also, there is a command line. Command line is similar to command line in Windows, if you know it, or in other operating systems. Here we should type different commands. Here we have to tell Stata what it has to do. For example, Stata do something. Well, once we say this, Stata will show the output in the main area. Well, what else? Also, we have a history window. History window records all commands we use in Stata. For example, look, here I have a first command and Stata shows me, let me enlarge it, and Stata shows what I did. I typed asterisk Stata do something. What else? Also, we have a variables window. Now it is empty because we didn't open any dataset in Stata, but later this window will be filled with different variable names. Well, usually we customize Stata to make our work comfortable and to make our work comfortable. How to customize Stata? You should use simple drag and drop procedure. And now everyone try to drag and drop variables window. You have to drag it here to the left side and drag and drop history window to the here. Please do this. You have to drag and drop. Get this type of command. If I have to repeat it, please indicate somehow.
Yes, can you please repeat it?
Yeah, look. In Stata, we can move small windows. To do this, you should put your cursor here, press left mouse button, and move it somewhere. And look, when you move the window, you can find different hints where you can place this window here, here, or here. For example, I want to move it here. Well, or I can place it here, or I can place it here. Something like that. Well, what you have to do, you have to reach such a view.
Evgeny Alexandrovich, I have a question. Which version of Stated should we upload, the MP version or SE version?
I recommend you to use MP version.
Okay.
But it's not a mistake to use SE version.
Got you.
And what is the difference during the work?
MP version can proceed large amounts of data, while to be honest, I don't think that we will use large dataset in this course because using large dataset requires huge power of your machines. Well, hence it doesn't matter whether you use SE or MP version. But in practice, for example, myself, I use MP version, as you can see.
Excuse me, can we do like switching the sites in Mac
Yeah,
on Mac OS?
yeah, for sure you can, but I don't know how to drag and drop windows in macOS. Well, if you don't know how to use it in Mac, probably you should Google it after the lecture, because it's not a serious problem if your windows are placed by default. So, okay, guys, next, please download a following data set. Look, here we have in the chart, I uploaded dataset L5 data. Please download it. Are you ready? Other students, are you ready? Fine. Now I'm going to show how to open this dataset in Stata. Please, first, see what I'm doing, and next, do the same. First, to open dataset in Stata, you have to check whether your file has DTA, whether the file is a DTA type file. Look, if you look at the file name L5 space data point DTA, it means that this file is saved in Stata format. Hence, this file can be opened in Stata. Well, to open this file in Stata, we have to follow a standard procedure. You should click File, Open, and next you should go to your folder to open this file. L5 data. The procedure is standard, and next you have to click Open. Well, once data open your file, you will see some changes. Let me show. First, you will see this phrase, use, and in quotations, you will see root to your file. Next, in your history window, you can find the same command. Well, also now we can find different variable names in the variables window. Now everyone, open this file in your program. To do this, go to File, Open, and find your file. Please type plus if you are ready. Type plus if you are ready. Good. Now we are going to analyze this data set. Look, I can enlarge this window, and what I have here I have two columns. One column is name, another column is label. Name column shows short variable names, and when we name any variable, we cannot use spaces. We should use this character. Well, and also we have label. Label is a long variable name, and you can assign any labels, for example, well, to our variables. You are familiar, by the way, with this data set. We used it a couple of weeks ago when we calculated means, standard deviations, and quartiles. How to use this data in Stata? First, now make notes or remember commands we have to use in Stata. First, a basic command in Stata is help. If you don't know how to do something, type help. For example, I don't know how to use help in Stata. Help me with help, please. And well, wait. For example, state help file in Stata. If you type help, a single help, Stata will show you notes or instructions how to find help files. Let's say you are trying to find out how to do something with about 3,000 help files and 4,000 pages of PDF documentation and so on. Here there is an instruction how to work with help file. Help is your main command, and it is command that you have to remember from the very beginning. Next, you can type help if you want to learn how to use help files. How to use help command. And here Stata explains how to use help command in Stata. First, there is a short description what this command means. There are several kinds of helps available to the Stata user. For more information, see advice on getting help. Next, there is a syntax. What does it mean? Syntax is a framework which helps us to use a command. What does it mean? How to read the syntax? First, there is a command name. Always, the first word in syntax is a command name. And we highlight first letter, or we can highlight first 3 or 2 letters. What does it mean? Well, in Stata there is a long version of the command help, or there is a short version of the command h. For instance, h help. My output is exactly the same, so it's not necessary to write help, help, or help something. It's sufficient to write h space something. Next in square brackets, you should put your tags. It could be command, another command of Stata, or topic you want to work with. Next element is about options. Comma, we separate main part and options with comma, and we use different options. For example, no new specifies that a view window not be open for the help topic, or we can specify name or marker, so on. By the way, usually we don't use these options. It's sufficient to use just a basic block to work with help. What else? In addition to syntax, there is a route how to use help command in Stata manually. Well, look, we have to click help and go to Stata command. And let me show you. Click help and look, in help tab you can find Stata command. And here you should type a command name, for example, help. Your output will be the same. Well, what you have to remember now at this point of time, in Stata there are 2 ways to do the same. One way is to write a command in command line. Well, write here something. You can write a long name of the command, a short name of the command, as you wish. Another way is to use buttons on your panel. For example, help, Stata command, so on. Well, next we have a short description of this command, and what is more important, we have examples. Well, if you scroll down, you can find, look, remarks and different examples. To obtain help for regress command, type help regress. Well, and sometimes we have video examples. Well, why Stata? Why we use Stata instead of RStudio or Python? Stata is simple, and one of the brilliant features of Stata is that it has a really good help. I don't think that it is the best version of help files, because I think that EViews program has better help files than Stata, but Stata also has a really good help files, and they are definitely better than that of Python or RStudio. Well, next. Okay, we learned first common help file. What else? In Stata, we can make notes. To make a note, you should write something, and your sentence must be started with asterisk. If you type asterisk, and if you write any text, my first sentence in Stata will record it, will show you this one. But if you don't use asterisks and type the same text, Stata will return An error. Look, command my isn't unrecognized. Well, please, my first command. Do this, my first command. Hope you are ready. Well, now we have to analyze our data set. What we have to do first? First, we have to look at our data. Well, there are two ways in Stata to look at our data. First way is to use browse command. Type browse and press enter and tell me what happens.
We can see a table in a separate window.
Right. If we type browse and press enter, Stata opens spreadsheet of our data. And this spreadsheet is similar to spreadsheet in Excel. So we have rows, columns, cells, we have some numbers in cells, but there is a difference. First, look, some cells have points, other cells don't have points. What does it mean? Look, cell with a point means that this cell is empty. No information is here. But if you have a cell without any character, letter, or point, it means that it's just an empty space. We don't have a no-name variable. It's just an empty space. You can skip it in your analysis. Well, hence all of these cells exists. These cells belong to this variable, and but these cells are empty. But these cells actually don't exist. Well, and they don't belong to any variable in your data. What else? In contrast to Excel, you cannot change your values now. Try out. Make double click somewhere. Nothing happens. Well, how to change your spreadsheet? Look, near the file, there is a button Edit Mode. Please click Edit Mode. If you click Edit Mode and confirm it, you will be able to change your cells. For example, you can replace 5 with 6. Do this, please. Hope you are ready. Next, now close this window. Another way to open the edit mode, type edit. If you type edit and press enter, you will open a spreadsheet again, but now you can change your values, for example, like this. To sum up, in order to open a spreadsheet with your data in Stata, you have to use two commands. One command is browse, if you want to read your data, to look at your data. Another command is edit. You can read your data and you can change your data a little. Well, what else? In addition, there is a command list. If you type list and press enter, Stata will show your spreadsheet in the main area. Look. For sure, if we use list, we cannot change our data set. We can look at this data set and that's it. Type list. Are you ready? Should I repeat something?
А можете повторить, пожалуйста, второй способ открывания файла с помощью
Yeah.
эдитора?
Let me make notes. To open spreadsheet, but without changes, browse or browse command. It is the first way. Let me close it. Browse command. Second, to open and edit command. Use edit. Let me show you everything just to make notes. And to open a data set in the main window, use list. Wait. Please remember these 3 points. 3 commands: browse or edit or list. Type plus if you are ready for the next step. Shall I go next? Shall I go on?
Yes.
Oh, thank you. Well, okay. We open data set. We see that we have some numbers. How can we analyze them in data? Well, we learned that in statistics, it makes sense to calculate averages, standard deviations, and so on. And we spend hours or even weeks for that exercise. Instead, we can do it much faster. To calculate averages and standard deviations, it is sufficient to type summarize command and a variable name. For example, sales region 1. And enter. And look what happens. This is your command and this is your output. State counts number of observations as number of non-empty cells. Next, it calculates a sample average, sample standard deviation, minimum and maximum. Please reach the same output. Okay, I see you already. Next, it's not very convenient to type such a long command name, a long variable name. Instead, it is more convenient to type just sum and make double click on any variable name. For example, double click here. And by the way, you can add more variable names. Double click here and double click here. And look. Get this output. Use double clicks to add your variable names. Good. Next, how to calculate median, quartiles, percentiles in Stata. To do this, you should a little bit change the previous command. You should select a single variable, for example, sales region 1, and you should add an option. To add an option, always separate. It is the main part. Some sales region. What does that mean? You tell you want to calculate a simple descriptive statistics, but in addition, you want to add details. Detail. If you add detail option, Stata will calculate detailed summary statistics. Reach this output. Type plus if you are ready. Well, interpretation. First, look. The first thing we have mean 10,594.8038. Exactly the same number as here. Also, we have standard deviation. Exactly the same number can be found here. And we have minimum value here and maximum value here. This column shows 4 smallest values and 4 largest values. Hence, it is a minimum and this is maximum. What else? In addition to standard deviation, Stata calculates variance, skewness, and kurtosis. What do skewness and kurtosis mean? Skewness is a measure of skewness of our distribution. How to interpret this number? You have to compare this number with 0. If skewness is close to 0, our distribution doesn't have a huge skew. So it's not skewed. Well, again, how to interpret skewness? We have to compare it with 0. If it is close to 0, hence skewness is small. If it is equal 0, hence skewness is absent. And again, how to interpret skewness? Always compare this number with 0. If it is close to 0, hence skewness is small. Kurtosis. Kurtosis shows whether peak of our distribution is higher than that of the normal distribution. Well, how to interpret kurtosis? We have to compare this number with 3. If kurtosis is close to 3, hence peak of our distribution is close to the peak of the normal distribution. Again, interpretation of kurtosis. Compare kurtosis value with 3. If it is close to 3, hence peak of our distribution is close to the peak of the normal distribution. Next, this is the median, 50th percentile. It is median. This is first quartile. This is third quartile. These numbers are percentiles, and some percentiles we have. Well, and for sure we have number of observations. Well, any questions?
I'm sorry,
Now,
but how to understand whether skewness is positive or negative?
skewness positive or negative, Stata automatically calculates it. You don't have, so you need just to look at these two numbers and compare them.
So
And
am
that's
I right that if skewness is more than 1, it is positive 1, and skewness is less than 1, that is negative?
I think now you shouldn't think about well, so you shouldn't care whether these numbers are positive or negative. You should compare skewness with 0. Let me type in the chat. Compare skewness with 0 and compare this with 3. You have to do this. Don't care whether they are positive or negative.
But then how do we define whether this the distribution is right skewed or left skewed?
And I would like to show you how, by the way, yeah, that's a good question. How can we define whether it is right skewed or left skewed? One way is to compare mean and the median. We see that mean is bigger than the median, right? Are they bigger? Probably yes. Definitely, mean is bigger than the median. Well, hence we should expect some extreme large values. Well, and probably our distribution cannot be symmetric. Hence, so there is a skewness problem in our distribution. But can we say that skewness is high? No, because our skewness isn't different from 0. So it's close to 1, but anyway, it's not 10, it's not 3, it's not 5. How it works, skewness and kurtosis. Let's do an exercise to illustrate it. Type edit, everyone, type edit and open the spreadsheet. And let's replace one value in our data set. Let's replace this value with something large. 1, 2, 3, 4, 5, 6, 7, 9. Something like that. Type any large number. Like this. Type any large number, sales region 1, and now let me show you one interesting feature in Stata. Look, everyone, find page up button on your keyboard. Find page up button and press page up. Do you have previous comment? Yes or no?
Yes.
Type it again until you reach this one, sales region 1 detail. If you have Mac or Linux or this way doesn't work, just type this command again, sum sales region 1, comma detail. And look what happens. Look, before our skewness was close to 1, it wasn't far from 0, but now it is 4. It increased. And kurtosis also increased. Well, it means that we change shape of our distribution. So skewness now is higher and kurtosis for sure now is higher a little. Well, and mean for sure must be higher than the median, which also indicates that there is a skewness in our data set. What else? For sure, we can think about skewness problem looking at skewness, kurtosis, comparing means and medians, but this way isn't very convenient. And to be honest, I never use this method. Personally, I prefer making histograms. How to make a histogram in Stata? You know that in Excel we can make a relative frequency or frequency histogram, but what about Stata? In Stata there are two ways. For sure we can use command line and type hist, meaning histogram, and let's use sales region 2. type hist sales region 2 and press enter and tell me what happens.
It will open in another window.
Yeah. It will open another window, and in this window you can find a histogram. This histogram consists of 4 bins. Each box, we name each box as a bin, and it is a density histogram. Well, what's wrong with this chart? If we use this way of making histograms in Stata, we cannot customize number of classes. Means classes are synonyms. We have 4 classes, but what if we want 5 classes, 6 classes, or 8 classes? What should we do? Right? What if we want to make a relative frequency histogram or frequency histogram? It's not a frequency histogram. We have to customize this command. How to do this? First, let's learn a manual way. Let me show you first. To make a histogram in Stata, go to Graphics. In Graphics, find Histogram. Again, go to Graphics, click Histogram, and open window. Look, this window is used to make a histogram. First, now we have to fill this window. You have to find a variable. You can type a variable name like this, or you can choose a variable name from the list. For example, I want to make a histogram for sales region 2. Next, you should define whether your data is continuous or discrete. Our data is continuous. Next, bins, number of bins. Enable this option and define your preferred number of bins. For example, 12. Well, also you can identify width of bins and lower limit of bins. But let's use just number of bins. Next, y-axis. Look, we can create a frequency histogram, or we can use fractions. I use relative frequency histogram or percents if you wish. Let's make a relative frequency histogram. Well, with 12 bins using sales region variable. Well, now you can click submit or OK. If you click submit, Stata won't close this window, but Stata will create a new window with your histogram. If you click OK, Stata will create histogram and close this window. Let me click submit. Well, and this histogram that we have. This is a histogram that we have. Well, now let's do it together. Or, yeah, one important note. Or you can use frequency histogram. If you do this, it will be not almost the same, but name of this axis is different. Well, now let's do it together. Go to graphics. In graphics, find histogram. And now let's use sales region 3 instead of 2. Sales region 3. And let's set 8 bands and set fraction. Let's use these options and click submit. And click submit. This is your histogram for sales region 3. Do you have the same? Good. And one option more. Look. Here also, we can use an interesting option. Well, let me show you over by. Click density plots tab. Click density plots tab and use add normal density plot and click submit. Density plots, add normal density plot and click submit. Your output must be like this. What does it mean? It means that you smooth your bins using a line. Well, guys, type something if you're ready with that. Well, yeah, I think so. We have to finish with data today, otherwise it could be too many information for you. And now we have to learn one theoretical tool. I suppose we have sufficient time for that. Well, at home, you have to learn more about frequency distributions in Stata. You have to read help files, watch videos, and to learn how to make them in Stata beautiful, how to combine different histograms in Stata. Well, yeah. And final remark about Stata. Final remark about Stata. Remember that we cannot save all of this stuff in Stata. If you click Save and open this data set, you won't see these outputs. How to save these outputs now? Select all, copy, and open your notepad. Paste to notepad. Again, select all of this, copy it, and paste to your notepad. And in the notepad, you can save all actions, all outputs you have, and save this file as usual. What about charts? Well, how to save this chart? Use standard procedure: file, save as, and look, data file type is Stata type. It is a GPH. It is a status type. Instead, use PNG or PDF or TIFF. I prefer PNG to save this chart, graph 1. At home, you have to save a lot of charts in using Stata and make one simple exercise. I will send you instructions. Now I'm going to show you topic. So of theoretical topic, well, what we have to learn in addition to Stata, we have to learn how to use standard normal tables and confidence interval. I think that we don't have sufficient time for confidence intervals, but for standard normal tables, definitely we have some time. Well, why we have to learn such a topic? 1 week ago, we learned empirical rule, and yesterday you said that you told that we can apply empirical rule to learn how many, to know proportion of observations falling into plus 1 or minus 1 standard deviation from the mean, or plus minus 2 standard deviations from the mean, and so on. So for sure, empirical rule is very beautiful, but to be honest, it's not very useful in practice. But this intuition, this idea can be easily used in practice using a standard normal table. Let me show you this thing. Well, imagine that your variable follows a normal distribution. You have something, for example, age follows normal distribution, or GPA, for example, can follow normal distribution. Well, and you want to know probabilities that probabilities that x lies between two numbers, x1 and x2. For example, what is the probability that a student X has a GPA between 5 and 6? What is the probability that GPA of a typical student in HEC is no less than 8? Another example, what is the probability that a stock market return is between 1 and 2%? Or what is the probability that stock market return is positive? We can answer to these questions using this tool. But there is a problem. We have different variables, right? Age, income, GPA, return, weights, and all of these variables use different units of measurements. Well, and how can we deal with that first? And second, how can we find such a probability? What is the mechanism behind it? Mechanism is simple. Look at this chart. Here I want to find a probability that my variable x lies between x1 and x2, two numbers. And what I have to find area of this shaded element. Look, so area of this element square, well, is a probability that x lies between this one and this one. Well, I mentioned problem with units of measurements. What does it mean? It means that different units of measurements, different units of measure place our distribution on different places on x-axis. Well, and it could be very inconvenient to use original units to find such a probabilities. Well, what should we do? We should apply a standard normal distribution or standardization procedure. What does it mean? We have to transform our variables using such a formula. Imagine that we know population mean and population standard deviation, and we know our variable of interest. It mustn't be average. So it could be any number. Well, and we have to apply such a formula to transform original units, dollars, percents, weights, to Z values. Once we transform it, average of our data must be 0. So we place middle of our distribution to 0, and one part of our elements should be negative, and another part of our elements should be positive. Well, for sure in practice, so there are some features related to this exercise, but now let's keep everything simple. Well, how to use it in practice? Let's do this exercise. Please read this thing and take a sheet of paper and write what is our mu, write what is our sigma, and what is our x1 and x2. Type plus if you are ready. Wait, let me fix it. read it and make notes. What is your x1? What is your x2? What is your mu and sigma? Type plus if you are ready. Good. Next. Go to the next slide. Well, yeah, mu is 22, sigma is 4. Our job is to find a probability that x is between 23 and 27. We see that units of our measurement are mpg, and our job, well, first, my recommendation for you as a beginners in statistics, always draw such a picture. We assume that distribution of our variable, gas mileage, is a normal distribution. This is our average, 22, and these are two our values of interest, 23 and 27. Well, and our job is to find a probability that x, or one serve's gas mileage, lies inside this area. Again, our job is to find a probability that x lies inside this area. Well, now we use original units of measurement, and to make our analysis simpler, we have to transform gas mileages to Z values. To do this, you should apply such a formula 2 times. Please, look. First, I have to find the difference between first x and mu divided by sigma, and here, sorry for typo, I have to use x2 minus mu divided by sigma. And I have two numbers, z1 and z2. And if I plot this again, the same distribution, my job, so instead of 23, I have 0.25. Instead of 27, I have 1.25. And my job is to find the probability that x is between 0.25 and 1.25. This is my probability of interest. How to find it? To find such a probability, we should apply a standard normal table. And this procedure consists of 2 steps. First step, so open standard normal table. Let's open it together. Let me show you. In your textbook, do you see my textbook?
Yes.
Yeah. In your textbook, there is Appendix D. It is a standard normal distribution table. You have to use it a lot to solve such exercises. Well, here you can find a simple example. Well, what we have in this table? In this table, we have probabilities. Well, and we have first column and we have first row. What do first column and first row mean? Well, how can we use it? Look, first, when you want to apply such a table, you should look at your first column, Z column, and you have to find appropriate number. For example, our Z is 0.25. I used my number is 0.2. Next, I have to find appropriate column looking at the first row. Appropriate form is 0.05. This one. And this number I am looking for, 0.0987. What does it mean, this number? It is a probability that x lies between 0 and 0.25. It is this area. And it's For sure, it's small. Next, next I have to find appropriate probability for this value, 1.25. To do this, I have to find 1.25, 0.3944. Well, and 0.3944 is area from this point, from the middle up to this line. Well, but my job is to find such an area. To find such an area, I have to find a difference between two probabilities. Look. Here we have two probabilities, and the difference between two probabilities is the solution. Questions? If I have to repeat, don't hesitate to tell it.
Евгений Александрович, а почему мы взяли 0.05 для того, чтобы посмотреть?
I was looking forward this question. Yeah, that's a good question. Guys, please remember. Remember it as a rule. This distribution is symmetric, right? Hence, and because of this, we look for areas from the middle up to a certain point. Look, always. And we don't look for areas from this point up to this line. We look just at the middle. And this is the reason why maximum probability in this table is close to 0.5. It isn't close to 0.1. It isn't close to 1. It's close to 0.5. Well, and sometimes we need to work with 0.5. For example, if you want to find this area, you could take 0.5 minus this number. Well, did I answer to your question? Should I explain it again?
Mm-hmm.
But what does this 0.05 stand for?
0.05 or 0.5?
What does this number mean?
It is a probability. Look, this distribution shows probabilities, right?
Yeah.
Area of this distribution is 1 because probability can be bigger than 1. If we divide this distribution into two equal parts, area of each part is 0.5, right?
Yes, that's clear.
Yeah.
But I mean the number in the header 0.05.
Ah.
The column that we're looking at.
Ah, I got it. Yeah, look. This row and this row. No, actually, I explain it here. Look. So in our table, row shows the value of z to the first decimal point, and the column gives the value of z to the second decimal points. That's it.
It's like the number that is going to be after the first decimal. Like,
yeah, exactly.
So if the probability will be 2.0.23, we will look to the column 0.03.
2.023?
Mm-hmm.
You mean, let me type in the chat. You
the
mean
X1.
2.0. You mean this?
No, I mean the probability. The task was to calculate the probability that is between 2 points. So X1 was 0.25.
Yeah.
And I'm saying if X1 will be 0.23, we will look to the column not 0.05, but 0.03.
Yeah, you're right.
So it's just the second decimal.
Yeah, you're right.
Okay, thank you.
That's it. Well, for sure. So this exercise is simple, and so you have to do a lot of similar exercises at home to master this skill and to understand how all of this stuff works. What else? Let me remind one interesting thing. Now you can relax. Well, instead we estimated means, standard deviations, so medians. In statistics, we often name these indicators as estimator. And one could ask me, what does it mean, a good estimator? What does it mean, a good mean, a good standard deviation? So what does it mean, good, in statistics? Good in statistics mean three things: unbiased, consistent, efficient estimator. Unbiased estimator means that expected value of the estimator should be equal to the population parameter. Consistent estimation means that standard error of the estimator should decrease as the sample size decreases. Efficient means that the variance of its sampling distribution is smaller than that of all other unbiased estimator of the parameter. And in this concept, there is a keyword: standard error. What does it mean, standard error? Why we keep in mind that standard error is a measure of accuracy. So we use standard error to know whether sample mean is a precise statistics. It is an indicator whether sample mean is a precise statistics. And calculation of sample error, standard error of the mean is simple. We have to take standard deviation and divide it by square root of the sample size. In case of population, when we know population standard deviation, when we don't know population standard deviation, use sample standard deviation and apply actually the same logic. Well, and at this point, I think we should stop this lecture and to summarize everything. Well, first, today, at this moment of time, you have to remember how to use Stata, how to repeat all things in Stata we learned before. Next, you have to you have to do exercises about probabilities at home. You have to be able to define that x lies between two numbers, probability that x lies between two numbers, or x is greater than one number or smaller than another number. It is important. Well, and finally, you have to think that, okay, so I calculated. You have to be able to calculate standard errors, and that's it. Next week, we have to continue this lecture, and next week we should learn more about probabilities, and we should discuss confidence intervals. Well, this is a pretty important and very useful thing in statistics. So now our time is almost up, and tell me please, do you have any questions?
Nope, that was clear. Thank you a lot.
Okay, and tell me please in the chat, what have you learned today? Mm-hmm. Yeah. Okay, good. So not bad. Well, at home you have to learn. So you have to do exercises about Z standard normal table and well, a lot of exercises, and you have to learn stata more. So you should learn how to combine different charts, how to make frequency distributions in stata, how to change colors, make your charts beautiful. So everything related to soft skills. That's it, I think. So our lecture is finished today. I think that you are tight, and so it could be too much for you to learn something else this week. Well, if you have any questions, you can ask. Now I stop the recording.